Objective, determining outliers. Vic number 1, you can mathematically determine if a set of data has any outliers by using the interquartile range. And remember, we abbreviate interquartile range using the letters IQR. Example number 1. Here's our data set 12, 10, 11, 7, 9, 10, and 5. Now these are not in numerical order, so we first have to put them in numerical order. I've done so here. To find an outlier, you need to follow these steps. So step number 1, find the IQR. So here's our set of data. First of all, you need to identify the median. So eliminate a high and a low until you have found the exact middle. So here is our median, 10. Now we're going to break this into 2 sections. Don't use the median. So we have 5, 7, and 9. And the median of this section is 7. So 7 is Q1. Q1 is equal to 7. Look at your upper section, your upper quartile, 10, 11, and 12. And the median here is 11. So Q3 is equal to 11. Q1 is 7, Q3 is 11. Find the IQR. So the formula for finding the IQR is Q3 subtract Q1. So 11 subtract 7 gives us 4. So our IQR in this set of data is 4. Step number 2, multiply the IQR by 1.5. It's always going to be 1.5 and you're always going to multiply. So take your answer from step 1 and multiply by 1.5. My answer was 4. 4 times 1.5 is 6. You're going to need this value. Step number 3. Determine the lower extremes. So in order to find the lower extremes, we use Q1 and we subtract our answer from step 2. Whatever the IQR times 1.5 gives you, and in this case it was 6, so I say Q1 minus 6, or remember Q1 was 7, so 7 minus 6 gives me 1. This is going to tell me my lower extremes. Anything less than 1 is going to be an outlier. To find the upper extreme, step number 4, take Q3 and add 1.5 times the IQR. So again, this is your answer from step 2, Q3 plus your answer from step 2. Q3 was 11, my answer from step 2 was 6, 11 plus 6 gives me 17. So my upper extremes are any numbers that are greater than 17. Step 5, check for outliers. So I'm looking at my data set, and you can look at it in numerical order or not, either one. And any outliers would be numbers that are below 1, there's my lower extreme, or above 17. And I'm looking at this data set and I don't see any. So there are no outliers for this set of data. We're going to do one practice example together. Determine if the data set has any outliers. So here's the data set and it's already in order numerically. And we're going to follow the same process. So first we need to identify the median, Q1 and Q3. So cross off a low and a high until we find the median. So here's the median. It's 5. And now I need to find Q1. So I'm looking at this set of data, 2, 2, 3, and 4. And the middle would be 2 and 3. So the average, 2 plus 3 is 5, and half of 5 is 2.5. So Q1 is 2.5. And we've done this in a previous exercise. So 2 and 3, the average gives you 2.5, which is Q1. Look at this set of data, 5, 6, 6, and 12. Find the median here. This will give you Q3. So 6 and 6 are both in the middle. 6 plus 6 is 12, and half of 12 is 6. So Q3 is 6. Again, it's the average of those two. Now, step 1 says find the IQR, Q3 minus Q1. Q3 is 6. Q1 is 2.5. So my IQR is 3.5. Subtract 6 minus 2.5. and you get 3.5. Step number 2, take 1.5 and multiply it by whatever the IQR is. So 1.5 times 3.5 is 5.25. Now to find the lower extremes, you're going to say Q1 subtract your answer from step 2. So subtract 5.25. Remember Q1 was 2.5. Subtract 5.25. And we get negative 2.75. It's okay to have a negative value here because we could have values of data that are negatives. To find the upper extreme, we take Q3 and we add whatever our value was from step 2, which was 5.25. Remember Q3 was 6, so 6 plus 5.25 gives us 11.25. So are there any outliers? Well, do we have any values in our data that were less than negative 2.75? No, our smallest one was 2. Do we have any outliers that are above this value? Because this is our upper extreme, above 11.25. Well, yes, we have 12. So 12 is an outlier for this set of data because it is greater than 11.25. 12 is greater than 11.25.